In this talk, a skill means that they are motion skills, okay? And learning can be achieved by the imitation. So imitation learning can be defined as the like this, a type of learning in which a naive student copies an expert, okay? There are lots of research works in the area of skill learning by imitation. But there are some missing points in the imitation learning community. What is the very important behavior among a whole set of behaviors? So we would like to define complexity. It's Mondrian and Pollack and Bushy, which pictures is most complex. It's the left side. I cannot take a look at the. Complexity can be defined by the regularity and so if an object is so much regular, then it cannot be considered as a complex. Likewise, the ideal gas is so random, it cannot be considered as the complex. In between, a liquid behaviors can be considered as a complex. Okay, by using neural complexity defined these pages, we can compute the complexity because the neural complexity can be defined the complex measure of brain signals based on a balance between regularity and randomness. This is a brain signals is very completely independent. So it is not complex, and this is nearly dependent. So this is also not complex, but this signals shows some balance between the regularity and randomness, so this is a very meaningful signals. Likewise, we would like to identify which motion trajectories are very complex. Actual movement skills can be obtained by signals and obtain the data sets, and then we can slice the data sets by using the time informations, and then we can reduce the data sets, and we can obtain the data like some kind of neural signals, and then we can analyze by use of the neural complexity, and then we can measure the complexity of the skills. There are 4 tasks. So right hand side, the most complex. Okay, it's because that it's regular portions and the random portions. It's combined.
Excuse me.
Yep.
It's a little bit more pleasant for us if you're not so close to the microphone when you're talking.
Microphone?
No, if you just step back a little bit from it.
Okay. Howling?
Well, it's fine. It's just when you're really close.
It is good?
That's good. Only when your mouth is very close to the microphone.
Okay.
Then it sounds strange.
Okay?
That's good.
Okay, yeah. Let's move down. Move on the down lower part of the slides. Is the skills of the writing learners. As we can expect it, it's these behaviors and these behaviors when compared to the behaviors, this is complex behaviors because this is a regular part. It's a very shallow entrance. So very cautiously, we have to put the waters into the bottle. So that behaviors, that skills is more complex than the pouring the water into the big bottles. Okay. So left one is a simple skills, and right one is a very complex skills. Most of skill learning technologies are confined to detect, learn the very simple behaviors. There are lots of complex skills in daily life. The passing a thread through an eye of needle is very complex, and painting a small part using a brush is very complex, and inserting a ring-shaped part into a hole is another complex skills. Okay, so we can watch out that these behaviors consist of three parts of the motions. One is approaching. Okay, so approaching here, and then some kind of very regular motions, and then departing motions. So this kind of motions shows a mixture of random and regular movements. So how can we detect the important portions? So regular motions, okay? So my students try to grasp this robot arm and teach how to paint this, okay? Approach and paint and depart. So we want to learn the skills, painting skills, okay? Together with the approaching and departing. So after demonstrating several times, you can watch out that the approaching allows large spatial variations, and departing also allows large spatial variations. However, in these paintings, very little spatial variations. And this kind of approaching motion and departing motion is so fast, relatively, than the part of these motions is very, very cautiously and takes a long time. So we can detect these portions, okay, by discriminating the small variations, spatial variations, and together with the taking the long time, okay. It's, so we can detect that kind of zigzag motions. So when we apply the existing approaches, so they did not detect the very small portion of the whole trajectories, because PCA means that they try to reduce the dimensions by extracting the large motions. So very small motions will not be considered as the very important. So the existing approaches cannot do it very well. But after detecting such kind of very important motions, that kind of painting motions can be copied successfully. Okay. Okay. It's another one. It's additional inserting a ring shape. It's okay. Okay. I will skip. After learning skills skills, those skills has to be reused, okay, by reorganizing some kind of skills. He is a boy. These 4 words, and she's not a girl. Consists of 5 words. And when we can reorganize like this, you can create the new sentence. He's not a girl by using these words. So likewise, we have to detect very primitive motions. And then those primitive motions has to be reorganized to have some kind of new behaviors, new skills. Okay? So we developed the autonomous segmentation technologies. This is open data. It's the kitchen daily life, the kitchen behaviors. So it's lots of behaviors: carrying, while, locomoting, reaching, taking something, opening the door, lowering on objects. So this semantics has been tagged by the some guys in TUM, Technical University München. So we use this data and then applied our technologies, and our algorithms can segment the motions almost same as the human does. And then we applied some kind of experiments, real experiments. So my students try to teach this robot arm to do the T services. Okay, so and then so this is data. Okay, it's motions, robot motions. This red one is a robot, O is a tea bag, it's a cup, it's a cattle, and hand. Those motion trajectories can be obtained by the motion captures. And then we applied our motion segmentation technologies. Then the software can obtain classify the totally 14 motion segments. Then motion segments can be primitive primitive motions, primitive skills. Okay, that can be reorganized. When we try to reorganize some kind of motions to achieve some task goals, we need some precondition and post-conditions. So we use the affordance. Among the many definitions of affordance, we use science effect equivalences. And then we're trying to find out the post-condition, precondition and post-conditions. And then you can classify these groups. It's approaching, delivering, grasping, releasing, and pouring. And those precondition and post-conditions can be mapped, can be transferred to these Bayesian networks, okay, in order to consider some uncertainties. So this is T-service Bayesian network structures used in T-services. There are 14 primitive behaviors, okay, skills. in order to do the T services, the robot has to expect what kind of situation he's undertake. That means that we have to networking all of behaviors like this. This is a fully connected finite state machines because some situations can be generated not by robot but by the other persons. Okay, like this. This is so this is a very simple way to create the finite state machines, fully connected finite state machines. All the behaviors, all the behaviors will be plugged into these architectures to have the finite state, fully connected finite state machines. It's when this kind of situations, instead of firing this section is will be fired because we put all the behaviors in to achieve the goals. This is the goals. Okay, so these two situations are met. This means that this state is the more this state is near the goals, okay, rather than this state. So we have to initiate these actions rather than the firing the other actions. Okay, like this. So it's a human snatches, okay? Then the robots, yes. So human helps moving the cups. So the robot did not to move the cups, okay? Directly moves the cup, yeah? Okay, so those primitive behaviors have been acquired by the analyzing the previous experiences, and then after the segmenting the acquired primitive behaviors, those behaviors are arranged to achieve the T services regardless of the change of the situations. In order to do, we have to plug all the behaviors into the some kind of fully connected finite state machines. Okay, this is the whole architectures of our own task skill learning framework. Thank you. Questions? Yes?
Sure. I was just going to ask if you tried anything else besides a fully connected finite state machine to represent the transitions between actions. Did you consider like a decision tree or anything similar with the?
Okay. In order in order to have this kind of fully connected finite state machines, okay?
Yeah.
Yeah, we simply use these architectures. This is the nominal sequence of action sequence of the plans.
Mhm.
Okay, and then we put this one. Okay, this is the goal-oriented directions, and then we put these switches. These soft switches, probability switches,
Right.
and then this one is this signal goes in, and this goes in, and when this one is selected, then three values. When we compare three values, we can have the big B1. So probabilistically, this behavior will be generated. Okay,
Yeah.
but this kind of situation, then this means that somebody helps the robot, okay?
Yeah, I understand the principle behind why you need to change states
Yeah.
based on, uncertain aspects of the environment.
Yeah,
And,
right. Yeah.
I
That
just-
uncertainty comes from the not by robot, but by some
Yeah.
kind of outsiders.
Other actors in the system.
Yes, you're right. Yeah.
Right? I was just asking if you considered using models other than finite state machines to represent
Uh-huh.
the ability to move between states
Uh-huh.
in the system. I was just curious because I found finite state machines to be very restrictive, especially when considering many actions with many preconditions and postconditions.
Okay. This is the precondition and postconditions.
Yeah,
This unit is a precondition and postconditions. Okay. Yeah, and there are sets of last, it's a motion sets, and then we plug this one to the switch systems. Then among the motion sets, one will be selected. If some kind of situations is more approaching to the goals, then that state will be selected rather than the others. That is yeah.
yeah. Okay, well,
Okay.
we can talk more
Yeah,
about
okay. Okay, thank you. Yeah, thank you for your participation here.